Okay, so for today, we are going to talk about some frequency tables to sort of help us determine the displacement of our data and the frequency in between certain intervals. But to start off with, we are going to talk about this one. So as a part of an environmental science project, you measure the trees in a park to the nearest foot. Your data is shown below, and you want to estimate the number of trees between 30 feet and 60 feet tall. So what is your estimation? So if we look, there's a couple of ways you can estimate about this. And you can pause the video and take a moment to try to determine it for yourself. If you look 30 to 60 feet tall, these fall within two of our data ranges, two of our intervals. So we have our interval of 26 to 50, and we have our interval of 51 to 75. So 30 to 60 fall within both of these ranges. So one way of thinking is 30 to 60, that's pretty close to 26 to 50. So it kind of fits that range. And so you could choose 44 as your estimation. That's a possibility. Another thought is thinking that because your data falls within both of these ranges, you could take the average, or you can find the mean between both of them. So you could add 44 to 31 and divide by 2, and that could give you your average, which I believe is 37. And these are both ways to estimate your data based off this table. Once again, it's an estimation, so there's no right or wrong answer. It's just what you think is true. All right, so now we're going to talk about what these frequency tables are and how to go about using them. So a frequency table, it shows the number of data values in a specific interval on a table. So these intervals, they cannot overlap, they cannot have gaps of numbers between them, and they're typically equal size. So if we look for this first interval, we have from 0 to 25, then we have 26 to 50, 51 to 75, and 76 to 100. Those are our 4 intervals we have in that last problem. So all of those intervals are just about 25 points. Our first one's 26, then 25, 25, 25. So you determine what your intervals are, and then you put the number of, or how frequent data values fall within those intervals. So we had 27 trees that were between 0 to 25 feet tall. We had 44 trees between 26 to 50 feet tall. We had 31 trees between 51 to 75, and 7 trees between 76 to 100 feet tall. So those are the frequencies that occur. So we're going to look and figure out how to create one of these frequency tables based off of some data values. So we have the number of home runs by batters at a local home run derby are listed below, and we're going to create a frequency table to represent this data. So we have all of this data. We need to create a frequency table for it. So once again, a frequency table, you must include your largest and your lowest number, and you can't have any gaps between them, so you can't miss any numbers. So our largest number is 17. Our lowest number is 2. So from our frequency table has to go at least from 2 to 17. Now if we think how many data points fall between 2 to 17, you probably want to do 17 minus 2, and that'll give you 15. But if you subtract 2, then you miss that value of 2 as well. So what you actually need to do is we're going to take 17 minus 1, and that will give us 16 spaces. That includes 2, because if you count 2, 3, 4, 5, 6, and count how many numbers are from 2 to 17, you're going to get 16 total numbers. So we need to create an interval that has a total of 16 spaces. So we need to split up 16 into 4 semi-equal intervals, or as equal as we can. Well, if you think 16 can be divided into 4 spaces, equally into 4. So what we can do is each of these intervals will be 4 spaces large. So if we start at 2, we think 2, 3, 4, 5. 2 to 5 is 4 numbers, or an interval of 4 large. Then the next number larger from 5, we go to 6. So then we get 6, 7, 8, 9. 6, 7, 8, 9. Number. And so that will be our next interval. We can keep going up with the same progression. So 10 to 13, 14 to 17. These are are intervals that fit all of our data. And they are equal in this case. Sometimes they might not always be equal, but we want to try to make them as equally as possible. But sometimes it doesn't always work. So now we have to figure out what the frequency is for each of these intervals. To determine our frequency, we need to count how many of our data points fall within each interval. So we're going to start off with 2 to 5. So I'm going to look for how many numbers fall between 2 to 5. So that is 1, 2, 3, 4, 4 numbers. Next, 6 to 9. 1, 2, 3, 4, 10 to 13. 1, 2, 3. And lastly, are 14 to 17. 1, 2, 3. So this is our frequency table. We have 4, 4, 3, in each of those. And that is how you create a frequency table from a data set. So let's see this next one. All right, the data below shows the battery life in hours for different brands of batteries. Create a frequency table to represent this data. So we're going to do this one together as well. So if we look, once again, we want to find our largest to lowest number. So our largest number is 22. Our lowest number is, I believe, 9. So from 9 to 22, this is our range of our data. So once again, in order to figure out how many spaces there are, or how many numbers there are between 9 to 22, we're going to take 22 minus 8, because we want to include 9, and that gives us 14. So 14 spaces. But if we think about this, 14 doesn't split into, we have 4 intervals here. 14 doesn't split into four equal times. If we take 14 and divide it by 4, we get 3.5. So in order to make sure we have semi-equal data sets, some of those intervals are going to have to be 3, and some of those intervals are going to have to be 4. And that's okay. It's okay to have some intervals just a little bit larger than the other ones. But the goal is to get them semi-equal, to be as close as possible to each other. We don't want like one to be 10 spaces and one to be 2 spaces, and one to be 1 space, and one to be 1 space. They all need to be semi-close. So 3, 3, 4, 4, that works. So I'm just going to start off with my lowest number, 9. I'm going to go by 3 spaces. So 9 to 11 is 3 spaces. Then the next number is 12. Go by another 3 spaces, and that takes me to 14. So 12, 13, 14. Then I go to 15, I need to go 4 spaces. So that takes me to 18. And then lastly, 19 to 22 is my last 4 spaces. So once again, depending on how you determine to lay out those data points, if you went 4, 4, 3, 3, your frequency table might be a little bit different, but that's okay. It's just a way to measure the data and look at the data size, depending on your intervals. So your intervals can change, and it's okay to have 2 separate or 2 different frequency tables for the same amount of data, depending on those intervals. So 9 to 11. 1, 2, 3, 4, 5, 6. 12 to 14. 1, 2, 3. 15 to 18. 1. And then 19 to 22. 1, 2. So that would be our frequency table of our data. So 6, 3, 1, 2. Very good. All right, so now we're going to talk about something called a histogram. So what a histogram is, it's a graph that can display data from our frequency table. And a histogram uses 1 bar for each interval on that table. So for each interval you had, you can measure the height of the frequency. So the frequency will always be your y-axis, your intervals will always be your x-axis. So for example, we have 20 to 30, you had a frequency of 2, so you've made your bar graph up to 2. Just like your interval, or just like your frequency table, this histogram will not have any gaps in it. The only gaps are if you have a frequency of 0, like we have between 80 and 90. Other than that, you should have a value in 1 bar for each interval you have. The difference between a frequency table and a bar graph is a histogram and a bar graph. A histogram, all of those bars are adjacent to each other. They don't have gaps in between them. A bar graph has gaps in between them, but these are all adjacent. You want them all to be as close as possible. And once again, your frequency is going to be your y, your x is going to be your interval. I'm sorry. All right. So we're going to learn how to create a histogram from a frequency table. So first things first, You're going to get some data, and you're going to have to create a frequency table from it. So the data below are the number of hours per week a group of students spent watching television to create a histogram of this data. So to start off with, you will need to create a histogram of this data. So take a moment, see if you can create a histogram of this, see if you can create a frequency table of this data, and then we'll move on to creating a histogram. So start off with your frequency table. Okay, so depending on how your interval was created, and what intervals you use for your frequency table, your table might look a little bit different than mine, but that's okay. So now we're going to create a histogram of this data. All right, so once again, your x-axis, that's always going to be your interval. So I'm going to start at 0. I'm going to go up to my larger values on my x-axis. So 0 to 3 is one interval, then 4 to 7, 7 down there. Let me erase. 4 to 7. And then we go from 7 to 12, from 8 or 13 to 17, and then our last one is 18 to 22. These are all our intervals. We need to put in a bar for each of these depending on the frequency. So frequency goes from 0 to 5 is our large size. So we're going to go from 0 to 1, 2, 3, 4, 5. So our first from 0 to 3, that has a frequency of 3. So I'm going to create a bar 3 tall. Next one is from 4 to 7, goes up 5 spaces. So I'm going to create a bar up to my 5th level. And this will be mine, 4 to 7. Next I have another 3. Then another 3. And then my last interval has a size of 4. So this will be a histogram of my data. Sorry. So on this next chart, see if you can do the exact same thing. See if you can create a frequency table and create a histogram of this data, just like what we did in that class. Create a frequency table and then use it to create your histogram. All right, so assuming you were able to create your frequency table, you should have been able to create your histogram. And so we had 4, 2, 2, 2, and 2, and that is your spread of data for your histogram. All right, last thing we're going to talk about, we have 3 specific types of histograms. So a histogram can be described in terms of their shape, so depending on how the shapes are, they might fall into one of these 3 categories. They might not. So you have a uniform histogram. A uniform histogram is special because the top of all of your data is roughly the same. It's not going to be perfect. It's not going to be completely the same, but it needs to be close. So a uniform histogram has roughly symmetrical data, or it's roughly equal data. Symmetrical histogram is where it's fairly even or fairly symmetrical on both sides of your data. So with the symmetrical data, you should be able to draw a line down the center of your data that should try to divide it into 2 equal pieces. Once again, it won't always be perfect, but we want to get close. And the last one is skewed data. So skewed histogram is skewed to a certain side. It might be skewed left, it might be skewed right, but it's leaning towards a certain side. The heavier part of the data is leaning towards a certain side. And so that is a skewed histogram. So what we want to do in this next slide is we want to be able to determine which of these frequency tables, or which of these histograms, sorry, that should be histogram. Which of these histograms are uniform, symmetric, or skewed? So again, this first one is going to fall under uniform, because if we cut right down the center, we have 2 symmetric pieces, or 2 symmetric histograms of our I can move this out of the way. 2 symmetric pieces of our histograms. This is symmetric. Symmetric. Our next one, if we look, our data starts all the way over here and then drops off and then picks up way over there. So this is obviously going to be skewed to the right. That is a skewed histogram. And our last one, we were to sort of draw a line. Most of our data is pretty close to that line. Some of it might be a little bit below, some of it might be a little bit above. But this is fairly uniform in our data. Once again, not every histogram will meet these patterns, but most histograms can be categorized under one of each of these. And that is where we'll call it for today. We'll practice more tomorrow. I can pull up my, there we go.